Alright, 14. Okay, for the question 14 here, the surface area of the sphere's spherical ball bearing in the diagram 14 increased at the rate of 4.2 pi cm squared per second when heated. So find the rate of change of the radius of the ball bearing where the radius is 3. Find the corresponding rate of change of the volume of the ball bearing. Over here, this question is very kind because it actually gives you the area formula and the volume formula. So basically, it's not too hard. So first important information is what is this one? 4.2 pi. So if you're not sure, I always teach my students see the unit. Do you see the unit over here is basically is a cm square per second. Cm square means what? Cm square is a unit we use for area, isn't it? So therefore, I understand this information is dA. S negative 1 is a time, right? Over dt equals to 4.2 pi. Yeah, this is the first information you must get it because this is the rate of change topic. Alright, so then the question asked me to find the rate of change of the radius. How to write this? I always tell my students, if you see the word rate, basically you can write the dt at the bottom. Rate of change of radius, that means is dr dt. So in order to get the dr dt, and because these questions over here, I can use any information I have. Okay, over here dA dt, right? So maybe I will take the area formula first. So therefore area equals to 4 pi r squared. Definitely I can differentiate my area, right? dA dr equals to 8 pi r. Okay, why I didn't choose the volume? Because the 4.2 pi information given here is for area. So if I choose the volume later, it's very hard for me to form the change rule. So in this case, choose the area will be easier. So I have the dA dr and I have the dA dt. I know I can form the change rule like what I teach you guys how to do last week. So if the dr on the top, you write dr and this is dt. Middle, these two terms must be exactly the same term over here. So basically it's dA and dA. Alright, so but before I substitute the dA dr into the dr dA, I have the r value. The r is equals to 3 is given here. So I kind of will substitute 3 here to get 24 pi. So therefore this is 24 pi. This is dA dr. So dr dA means what? It's basically just flip over. So flip over, this one will give you 1 over 24 pi. dA dt have already is 4.2 pi. So pi and pi I simplify. So basically what I get is 4.2 divided by 24. So which is 0.175. Alright, this is the rate of change of the radius. This is how we find using the change rule. Alright, then corresponding rate of change of the volume. So when I see the word corresponding, I guess they are using the same information above. Because it's something like at that moment, what is the rate of change of volume? Something like that. So therefore, I will use back r equals to 3 in this question. But because the question one rate of change of volume, I know rate mean dt, volume mean dv. So this one is dv dt because time is always at the bottom of your fraction. So therefore, it's dv dt. So I want to form the change rule first. So this is dv, this is dt. And middle one, definitely we know we use the radius, dr and dr. Alright, we have the dr dt, which is we just found. This is dr dt, right? We have the dr dt value already. So what I want to do is, I want to get dv dr. dv dr is very simple because we have the equation of v already, right? 4 over 3 pi r cubed. So dv dr basically is differentiate this one, I get 4 pi r squared. And I know my r is equals to 3. So 4 pi 3 squared is 9. So I got 36 pi. So therefore, I substitute everything into the change rule. So this one is 36 pi multiply 0.175. So multiply 36. Yep. So I will say 6.3 pi, or you can type everything in your calculator and get something like 19.72. 79 I mean 79. If you love about unit, you can always write cm cube per second. Yeah, so far I checked the marking scheme. There doesn't minus mark if you didn't write the unit. So I guess it's okay, but you better double confirm with your school teacher. Alright, so far any problem? Should be okay, right? This is rate of change question. Basically, yeah, this is kind of the difficult part of rate of change, because this kind of rate of change question is what this kind of rate of change question, basically you need to find the first rate of change value and then use the first rate of change value to find the second rate of change value. And sometimes you will have the two different equations, you have two different change rule. So this one is considered quite hard. Normally SPM one is just like one change rule, and then it give you the information is about 3 marks, and then you just substitute into the correct change rule, you will get the answer. So if the examiner want to make this kind of question K-bar, he basically will form a question require 2 change rule. So basically you need to have more than one equation, and then you need to differentiate 2 different equations and then substitute into each other. Yep, I hope you can understand. Alright. Okay, number 6. This question is not really hard, but it's not really easy also if you do not know how to do this. Yeah, I just realized I forgot to wear my spec. No wonder I feel a bit uncomfortable. Okay, so diagram 6 actually show the part of the curve y equals to x cubed minus x, and the curve actually passing through the point P. Alright, so first thing, find the equation of tangent of the curve at the point P. So we already learned like how to find the equation of tangent here, isn't it? So we follow back our step here. So our first step is doing the dy dx. So I will just do the dy dx. So dy dx, basically you will get 3x squared minus 1. Differentiate the curve equation. Second step, we basically substitute the x value into the dy dx. What is our x value at P? Which is 2. X equals to 2. So 2 squared is 4. So it's 12 minus 1. So it's 11. Alright, we get the gradient. Then the third step, we form the equation by using the y minus y1 equals to m x minus x1. Yeah, I still have a lot of students love to use the y equals to mx plus c to actually find the equation. Yeah, you can do that. You are always free to use the formula. As long as it's a straight line formula, should be good. But I prefer this one. So I will do y minus 6 because my y1 is 6 equals to 11, x minus 2. Alright, so my y should equals to 11x. This one is minus 22 plus 6 minus 16. So this one is my equation of tangent. So I just simplify it, move around some algebra thing. Alright, so then I easily get my 3 marks. Follow the 3 step, dy dx, sub x value into dy dx, form the equation. Alright, then given the tangent to the curve at the point Q is parallel to the tangent at P. Find the coordinate of Q. Okay, this one is a bit hard if you do not know what the question is saying. Okay, what the question trying to say over here is basically you have another equation, another straight line which will parallel to your tangent. So I kind of draw my tangent over here. Okay, it's not so perfect, so I try to draw something more perfect. Okay. Oh my god, it just can't draw a perfect line. Okay, last time, if not perfect, then it's fine. Alright, so assume this is a tangent line, even though it looks very ugly, but just assume it's okay. So that means I should have one more line here, and this line must be parallel to my tangent, and then this line will touch one point at the curve, which is a tangent to the curve as well. So I do not know where exactly the point, so I will just assume it's somewhere here. Because my tangent line is just freehand draw, so the coordinate I plot is like estimate one. Okay, most likely it's wrong maybe. So it can be any point on the curve, we don't know. So what I know is my tangent gradient is 11. So this line gradient must be 11. This is the purpose of parallel, right? So therefore, how to find the coordinate q, because the question asked me to find the coordinate q, right? So the very important information I understand over here is my dy dx is equals to 11, because they have the same gradient, right? These two lines have the same gradient, and I have my dy dx is over here. So therefore 3x squared minus 1 equals to 11, 3x squared equals to 12, x squared equals to 4, x equals to positive negative 2. And positive negative 2 over here, positive 2 I already used for coordinate p. You see the coordinate p, is it x equals to positive 2? So therefore, for the q, I will use x equals to negative 2. And because it's tangent to the curve, so definitely touch the curve as well. So I will sub in my curve here, negative 2q minus negative 2. So y should equals to negative 8 plus 2 should be negative 6. So therefore, my coordinate q over here is negative 2, negative 6. So therefore, my coordinate q should be somewhere at the bottom. Somewhere here maybe. Yeah, should be somewhere like this. Yeah, because the coordinate is negative 2, negative 6. Okay, so far can understand, right? This is the meaning of parallel because they have the same gradient. This is the reason why I make the dy dx equals to 11. Alright, so last one is basically some extra knowledge. So the question said tangent to the p meet the normal to the q at the point A. So okay, this tangent at the point q going to, this is q, right? Going to meet the tangent at the point P at the coordinate A. So, and then the tangent at the point Q meet the normal of the point P at the B. So normal at the P here going to meet at the point B here. Alright, so they ask you to state the shape of the figures A, B, A, P, B, Q. Obviously, you know this line is parallel to this line and QB is parallel to the AP. So this one is basically is parallelogram. Okay, so yeah, it might be rhombus, but I'm not sure. Is it 4 line also same line? So I will write parallelogram because rhombus is one of the parallelogram also. Okay, yeah, I don't like pronounce parallelogram. Oh my god. Alright, so